Okay, welcome to the Dublin Academy of Maths. Now today it's Leaving Cert Ordinary Level Maths Series 3 Episode 7 and it's Paper 1 and we're doing calculus. Right, and today we're going to talk about when the slope is equal to 0. Okay? Now these are the maximum and minimum turning points. Minimum turning points, maximum. Okay? Now, so we have a problem, okay? Well, let's just talk about this here is now, just to kind of emphasize what Newton did. Like this is a radio dial, okay, or a music dial of such. And when you turn that, you change the frequency, okay? You can change it to that type of frequency, and that is reflective in the bass or the tone of the music. So you can see that, and I've written out a few things here that Newton has kind of been an influence on regarding derivatives. Now the problem here is we have a local maximum and a local minimum point. Now by observation I can tell you which one is which. But if you're just given the function, say y is equal to x cubed minus 9x squared plus 15x plus 2. Now you know that the derivative of this dy dx is equal to 3x squared minus 18x plus 15. Okay? Now we know that when that at this point, when that's equal to 0, say this dy is equal to 0, these are related to these points. Okay? So I have to find out which one when I do find my points, which one it is, a local maximum or a local minimum point. Okay, so so what we do here is that we have to find the values of x. Okay, so given the slope, you can find the points of x here. Okay, those points here. So you, well, in this case I'm going to clean this up because I can divide across by 3. Okay, and then I can factorize it. What are the factors of x squared when added will give me minus 6, the coefficient of the middle term, minus 6. So the factors of 5, so the factors are 1 by 5, are minus 1 by minus 5. Which of them add to give me minus 6? This gives me 6, this gives me minus 6. This is the 1. X minus 1 by x minus 5. Okay, so they're the factors, and the solutions are x is equal to 1 or 5. Right? Now, for me to find out the corresponding y values, I have to put it back into the equation. Okay, so I'm going to put it back into the equation. Now before I continue on, the range here is, what's the period? Well, you can see that the period is starting to repeat here. Okay? Do you get that? So it's 3 units to here, and then it's 3 units to here, so it's 6 units. Okay, so the period is 6 units. Okay? And the range goes from the height of the x value, so the range goes from 1 to minus 1. Okay, so the range will go from 1 to minus 1. Okay? And that's how you write the range, 1 to minus 1. So we're back up on this equation. I need to rub out because I need space. So we've got this question, and we've got x is equal to 5 or 1, because we found out the slope was equal to 0 at that point. Okay, so now we have to find the corresponding y values. Y is equal to, into the original equation, always the original equation, even for functions or anything relative to functions and simultaneous equations, lines and circles. So I put in my 5 value, and I have 5 cubed minus 9 times 5 squared plus 15 times 5 plus 2. Okay, and the answer comes out as, so when I determine all this, it becomes minus 23. Okay, so that value is 5 minus 23. So now we've got one set of points. Okay, so when x is equal to 5, now we've got x is equal to 1. Okay, so we put in again, y is equal to 1 cubed minus 9 times 1 squared plus 15 times 1 plus 2. And we add them all up and it comes out to, where are we? It comes out to 9. Okay, maybe I should just do this. So this is 1, 9. So now these are my two sets of points. So now I'm trying to find out which one is which, the maximum, the local maximum, or the local minimum point. Alright, so I need to go back to my original derivative. Okay, so I did the original derivative, which was dy dx. Do you remember what it was out as? 3x squared minus 18x plus 15. Now I can reduce it down, dividing across by 3 minus 6x plus 5. Okay? Now, for me to find which point these are relative to, like local maximum or local minimum point, I need to derive the equation again. In other words, the derivative of the derivative. Okay? Which is actually, this is speed or velocity. So you're actually finding out the peak at which these things happen, right? Now, so I'm going to derive it again. This becomes 2x minus 6. Okay? Now I reintroduce my 1 value. So I've got the second derivative, 2x minus 6. I put in my values for x is equal to 5. I put them in, 2 times 5 minus 6 is equal to 10 minus 6 is 4. So that's a plus, right? Now remember that. So you got a plus for this. Now if you get a plus answer, it means it's a local minimum. Quite the opposite to local maximum, because you would imagine that because it's a plus it would be a local maximum, but it's not. So if you get a plus for an answer, you got a local minimum. And to prove it, I'm going to put in 1 in for x to get the other point. So 1 in for the second derivative. 2 times 1 minus 6 is minus 4. And this is the local max. Okay, now I can say that the points containing the point with 5 minus 23 is a local minimum point. 5 minus 23. Okay, and the local maximum point, which became out of minus 4, was 1, 9. Okay. Now this is kind of a bit confusing. So, but anyway, there are the results, and I'll just recap that again. If you get the second derivative and you put your values x, y into it, but it will correspond to the x value. If you get an answer as a plus, it's a local minimum point. So I've got, the last time we had 1, 9. Okay, so 1, 9 went in and it became a plus. If it becomes a negative and you put in your values into the dx squared, if you put your values in there for the last points was 5 minus 3. So if we put in 5 for x into the second derivative, and I get a minus, that's a local maximum point. In other words, it's up there. Okay, so that relates to 1. That relates to 5. What's a 5? It was way down. But 5 minus 23, so it's all the way. It's way down here somewhere. Okay. I should have a bigger graph, but anyway. But you get the point here. Now, is there anything else to add to this? Maximum minimum turning points is when the slope is equal to 0. Right. We can translate from a function to a quadratic line using slopes. So this all comes in regarding slopes and finding other possibilities with them. Now there's nothing else in this regarding. We'll just have a look at the questions now. Right, I hope that's a bit clear. Maximum minimum turning points, get the second derivative and then put them in. Depending on your answer, minus becomes a maximum, a local maximum, and then a positive result gives you a local minimum. Now here's some questions here. Find the maximum and minimum points and determine which is either. Okay, so get dy dx, you get an equation, solve the equation. Okay, you get a quadratic in this case, get the quadratic, find the factors, find the roots, get the second derivative, put the roots in and see which one gives you well, find out the maximum and the minimum points first, and then find out the second derivative, and you'll be able to find out which is the local maximum and the local minimum point here. Now this question here is going to present some difficulties, and this is just normal factors with common terms. Okay, so here will be x squared, actually it's a common term, take it out, minus 3. Okay, so you know that's equal to 0, x is equal to 3, x is equal to 0. Alright, so I'm practically doing the question for you, but you have to be very wary that you have to factorize, and then get your factors, and then you get your roots. Okay, it's everywhere all over this paper 1 with functions. Okay, and we've done functions in series 2. Now, this is question paper 2010. It just seemed the most appropriate. I didn't look at 13. I'm going to leave all the rest of the videos paper questions till the end, and I'm going to you're going to have to buy into them, buy into the series. Anyway, I've talked about the series before. Well, let's have a look at this. 2010 paper 1, let fx is equal to this, x minus 5 over x, not x minus 5 all over x. Okay, get the second derivative. That dash means get the second derivative. Well, this is obviously some sort of product rule. You can bring it up and make it equal to x minus 5 times x to the power of minus 1. I mean, it's very simple that way. Okay, so you may have to mess around with these, right? Find the coordinates of the tangent of the curve f of x, which is this, is parallel to the line y is equal to 6x. I can know the slope there. Y is equal to mx plus c. And this is a parallel line, so therefore the coordinates will be the slope will equal to 6. Alright, now that's enough said about that. But you see what you're doing here? You're messing with slopes. You're messing with coordinates, and now putting the coordinates into the original equation, the y, and then putting them back into the derivative to find out which is the local maximum. So the second derivative. Okay, finding your solutions of x. Right, so x, we factorize and we find the factors, find the roots. And the same thing is happening all over again. The coordinates of the tangent curve, so it will be the equal slope. Now there's not much more I can say about that. We will come across local maximum and minimum points next in the future. This is near the end of the video series. So this is series 3, and there will be probably an extra 4 to 5 videos on questions. Okay, now it's 20 euros per series, and it's dublinacademy@gmail.com. Or www.dublinacademyonline.com. Okay, there's my webpage. Should be up by now. So that's everything. Thank you. Do those questions.